Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's session, we are going to discuss about what were the theories that were proposed for getting a better knowledge about mechanism of corrosion reaction. That is what we call it as theories of corrosion reaction. And in theories, we have two different approaches. One is dry theory, or it is known as chemical theory of corrosion. And the second one, it is wet theory, or electrochemical theory of corrosion. So, and then coming to this first one, dry theory, it is again subclassified into three different types: oxidation corrosion, corrosion by other gases, and liquid metal corrosion. So, let us start with different theories that were proposed for explaining the corrosion reaction to take place. So, as I told you, there are two different theories that were proposed for explaining the mechanism of corrosion reaction. And first one, it is dry theory or chemical theory of corrosion. So, coming to dry theory or chemical theory of corrosion, this is purely due to the attack of atmospheric gases like oxygen, hydrogen sulfide, oxides of sulfur, similarly oxides of nitrogen, and any anhydrous inorganic liquid that is going to attack the metallic surface in immediate proximity. So, what happens actually when any gas it is going to attack on the metallic surface, say for example oxygen. So, it is able to form one metal oxide layer. So, and that extent, that metal oxide layer will decide whether further corrosion reaction takes place or not, because the extent of corrosion reaction, it is purely dependent on two different points. One is chemical affinity that is existing between corrosive environment as well as the solid metallic surface, and the second one is the ability of the reaction product on the metallic surface to form a protective film. So, as I told you, this dry theory or chemical theory of corrosion, it is again subdivided into three different types. One is oxidation corrosion, second one is corrosion by other gases, third one is liquid metal corrosion. So, let us start with oxidation corrosion first. So, this type of corrosion reaction mechanism involves, that means corrosion reaction takes place which is purely due to the attack of oxygen, atmospheric oxygen, directly on the metallic surface. So, this occurs by the direct action of oxygen at low temperatures on alkali and alkali earth metals. So, at higher temperatures, almost all the metals involved in oxidation. At low temperatures, if oxygen is going to attack on the metallic surface, then we can expect the metal oxide layer formation. At high temperature, almost all the metals will be oxidized. That means they involve in oxidation. As a result, metal oxide layer will be formed. So, if you notice, in general, we represent metal as M. Generally, metals have a tendency to involve in oxidation by losing electrons. Say, for example, I represent metal by the letter M. It is able to lose 2 electrons and thereby converting into its corresponding metal ions, that is 2M plus. So, these metal ions, say for example, this is the metal block which is represented like M, metal block. So, upon which oxygen is going to attack, which is atmospheric oxygen, because oxidation corrosion, it is purely due to the attack of atmospheric oxygen only. So, this metal will have a tendency, what it will do by involving in oxidation, by losing electrons. So, it is able to convert into corresponding metal ions. These metal ions will try to diffuse in outward direction along with the electrons. The metal ions that were released due to the oxidation of metal, they try to diffuse in the outward direction along with the electrons. Meanwhile, due to the attack of oxygen on the metallic surface, what it will do, it is able to gain the electrons that were lost by the metal by involving in reduction. So, by involving in reduction, oxygen, atmospheric oxygen, after attacking the metallic surface, it is able to involve in reduction by gaining of electrons that were lost by the metal and thereby producing corresponding oxide ions, O2 minus ions. So, O2 minus ions are available on the surface and these metal ions will try to diffuse in outward direction. At the same time, these oxide ions which are trying to diffuse in inward direction. So, along the surface of the metal, so these two metal ions will combine to form, metal ion and oxide ion will combine to form a metal oxide layer. So, along the surface of the metal, what will happen? Oxide ions as well as metal ions combine to produce metal oxide layer. That means if you notice the metal block, this is M. So after the entire reactions get completed, there is a formation of a metal oxide layer on the surface. So this is what is happening after the attack of atmospheric oxygen on the metallic surface. This is metal oxide layer that is produced. So this will have generally a thickness of 300 angstrom units. The metal oxide layer that is produced will have a thickness of 300 angstrom units, and nature of this metal oxide layer that was produced will decide whether further corrosion reaction takes place for the underlying metal or not. So this is the underlying metal, whether it involves in corrosion reaction or not. It will be decided by the nature of this metal oxide layer that was produced. So coming to this part again, due to the attack of atmospheric oxygen directly on the metallic surface, what will happen? That oxygen is able to gain the electrons by involving in reduction which were released by the metal. So as a result, it is able to produce oxide ions. These oxide ions will try to diffuse in inward direction. At the same time, metal already it has converted to its corresponding metal ions by losing electrons involving in oxidation. So these will try to diffuse in inward direction. So along the surface, what will happen? These metal ions combine with the oxide ions, thereby producing metal oxide layer on the surface of the metal. So generally this metal oxide layer produced will have a thickness of 300 angstrom units. So this layer itself is able to decide whether further corrosion reaction takes place or not. So as I told you, basing on the nature of the metal oxide layer that was produced, we can decide whether further reaction takes place or not. So basing on that one, it is of 4 different types. So as I told you, this is the metal block which is represented by the letter M. So by losing, this is in general I have written, valency of any metal will be represented like N. So N number of electrons. By losing N number of electrons, it is able to convert into its corresponding metal ion, that is Mn plus. So these will try to move in upward direction. That is, it is try to diffuse in upward direction. So due to the attack of atmospheric oxygen, by involving in oxidation, by taking these electrons, oxide ions will be released on the surface. So along the surface, if you notice, along the surface, these two combine to produce a metal oxide layer. This is the metal oxide layer which will have a thickness of 300 angstrom units. 300 angstrom units. So basing on its nature, as I told you, it is of 4 different types. 4 different types of layers will be formed. First one, it is unstable. If the produced metal oxide layer, it is purely unstable in nature. If it is purely unstable in nature, then it is involving in decomposition, thereby converting into metal and oxygen again. That means backward reaction will take place. So if it is the first case, unstable metal oxide layer it is produced. This is the metal. Due to the attack of atmospheric oxygen, a metal oxide layer will be produced. So if it is unstable in nature, then what will happen? It will come back to the metal and oxygen again. That is, it will decompose. It will decompose, will come back to oxygen, will be released into the atmosphere, and metal gets separated from the oxygen. So we can notice this kind of metal oxide layer formation in the case of noble metals like platinum, gold and silver. So due to the attack of atmospheric oxygen, one metal oxide layer will be formed, and if its nature it is purely unstable in nature, then what will happen? It involves in backward reaction. That means it purely involves in decomposition, thereby bringing back metal and oxygen separately. So in this case, further corrosion reaction will be prevented. That means stopped. So that means in the case of noble metals like silver, gold and platinum, further corrosion reaction will be prevented. So if it is for the second case means the produced metal oxide layer, it is purely stable in nature. At the same time, it is purely non-porous in nature. Stable metal oxide layer if it is produced. This is the metal block. Due to the attack of atmospheric oxygen, stable metal oxide layer if it is produced, then It acts like a protective film. It acts like a protective film. Produced metal oxide layer, if it is purely stable in nature, so it acts like a protective film, thereby it prevents further corrosion reaction for the underlying metal. Protective film in the sense impervious in nature. Impervious means it doesn't allow the penetration of oxygen onto the underlying metal. So it acts like a protective film. As I told you, that it acts like a protective film. Hence, further corrosion reaction will be prevented. So example for metals for this kind of metal oxide layer that was produced is aluminium. We can say aluminium is the best example. Similarly, tin, lead, copper also some examples for stable metal oxide layer formation. So coming to the third one, that is if the produced metal oxide layer is purely porous in nature, that means it will have small pores on the surface. Pores means small holes. Where having very less diameter, small pores will be present in the metal oxide layer that was produced. If such kind of porous metal oxide layer, if it is produced, which is having pores or cracks, then it becomes easy for the atmospheric oxygen to penetrate onto the underlying metal. Because pores were present, just like the example of, you consider the example of sponge. If sponge it is kept in water, then because of the presence of pores, it is able to absorb the water content. Just like that, the produced metal oxide layer, if it is having pores, it becomes easy for atmospheric oxygen to penetrate further onto the underlying metallic surface. As a result, different new layers will be formed till the entire metal gets disintegrated. This will be a continuous process. Example for this type of metals in which we can see porous oxide layer means lithium, sodium, potassium, beryllium, magnesium and calcium, which come under alkali and alkaline earth metals in the periodic table. Coming to the fourth, that is if the produced metal oxide layer is having a nature of volatile. Volatile means easily gets evaporated. That means it will evaporate and leaving behind the underlying metal for fresh attack of oxygen, atmospheric oxygen. So this is what here it is mentioned. A volatile metal oxide layer, if it is produced, which is able to involve in evaporation as soon as it is formed, thereby underlying metal surface becomes exposed for the further attack. Hence, a rapid and continuous corrosion reaction will take place that will lead to the severe corrosion, that is loss of metal. Till the entire metal gets disintegrated, it will continue. Example for this type, it is molybdenum oxide. So these things again I am going to explain. First case, if the produced metal oxide layer it is having unstable nature, then what I explained, it is able to involve in decomposition, that is involving in back reaction. As a result, we will get oxygen and metal will come back. And what is the second layer? If the produced metal oxide layer, if it is purely stable in nature, that means it acts like a protective film. And the third one, it is if the produced metal oxide layer, it is purely porous in nature, that means it is having small pores or cracks. If you notice, it is having small pores, or we can call them as cracks. So these are able to penetrate atmospheric oxygen onto the underlying metal. So it becomes an advantage for oxygen to penetrate onto the underlying metal, so that it is able to continue for further corrosion reaction. So and coming to the next case, that is fourth one. If the produced metal oxide layer, it is volatile in nature, easily gets evaporated, leaving behind this underlying metal. This is the underlying metal. As it is a volatile in nature, what will happen? It easily gets evaporated. Leaving behind the underlying metal for fresh attack of atmospheric oxygen. So as a result, a new layer of volatile nature will be produced, and this process will be continuing in a faster manner till the entire metal gets disintegrated. So this is about oxidation corrosion. That means purely due to attack of atmospheric oxygen. So far what we have discussed. What is the second type of dry theory? First one, it is oxidation corrosion. Second one, it is corrosion by other gases. That means in this, other than oxygen, if any atmospheric gas is going to attack the metallic surface. Say for example, oxides of sulfur, chlorine, fluorine and hydrogen sulfide. So if these are going to attack the metallic surface, say for example, I have considered attack of chlorine on the surface of silver and tin. So same gas attack on the surface of two different metals. I am going to take it as an example. So if chlorine gas, atmospheric chlorine gas is going to attack on the surface of the silver, at the same time on the surface of tin metal, what will happen? Let us see. So coming to the mechanism part, if chlorine is going to attack on the surface of silver, then it is able to form silver chloride as a layer on the surface of a silver block. At the same time, it is going to attack on the surface of tin. It is going to form stannous layer on the surface of the tin metal. So one is acting like a protective film, other one is acting like a non-protective film. So how it is decided, we have to know. So this will be decided by knowing the statement of Pilling-Butterworth rule. By knowing the statements of Pilling-Butterworth rule. Pilling-Butterworth rule will include two different statements, 1 and 2, which are able to tell us about ratio. About one ratio that is called Pilling-Butterworth ratio. So it is defined as the ratio of volume of metal oxide layer to volume of actual metal that is taken. So if you are getting this answer, that is result, ratio answer as greater than 1, when it will become as greater than 1, when it is going to increase, if numerator value it is going to increase, then answer will also get increased. That means volume of metal oxide layer, if it is greater than the volume of actual metal that is taken, that is what will come under statement 1. See, statement 1 of Pilling-Butterworth rule states that if the volume of metal oxide layer produced is greater than the volume of metal from which it was formed, then this produced metal oxide layer will act like a protective film, and hence it is able to protect a metal from further corrosion reaction. So this is the mechanism we have to adopt for silver metal. On the surface of silver, if chlorine is going to attack, then what will happen? Silver chloride will be produced. So it is acting like protective film, because obtained silver chloride layer volume, it is greater than the volume of actual metal silver. That means that ratio value you are getting as greater than 1. Hence it is able to protect the silver metal. Whereas in the case of tin, which is attacked by the chlorine gas, atmospheric chlorine gas, and stannous chloride layer that was produced. So what is happening in this case is statement 2 we have to apply. So in statement 2, what is going to reveal us is, if the volume of oxide layer produced is less than the volume of the metal from which it was formed, then this protective film will act as a non-protective film, and then it involves in corrosion reaction. That is happening in the case of stannous chloride. This is purely due to the ratio that is obtained is less than 1. Less than 1. Less than 1 you are getting as answer. Then what will happen? It acts like a non-protective film or a porous layer, so that it will be continuing with the further corrosion reaction. So this is about corrosion by other gases. We have to adopt the mechanism by using the statements of Pilling-Butterworth rule for getting a clear idea about corrosion by other gases. If the produced metal oxide layer is greater than the volume of actual metal from which it was produced, then we will get greater than 1 as the answer for ratio, specific volume ratio. Then what will happen? A produced metal oxide layer will act as a protective film. And in the other case, if the volume of the oxide layer produced is less than the volume of the actual metal, then we will have to lack non-protective film. In that case, we will get less than 1 as answer for the ratio. And what is the third type? Third one, it is liquid metal corrosion. Liquid metal corrosion. So it is purely due to, that means it is produced due to, or this type of mechanism we have to adopt in cases like when any solid metal or its alloy is coming in contact with any liquid metal upon its surface. That means if any liquid metal is going to flow on the surface of the solid metal or its alloy at a high temperature, then we have to adopt the mechanism of this liquid metal corrosion. So there are two things that we are going to adopt during the mechanism part. When any liquid metal comes in contact with solid metal at high temperature, there are two different chances. One is either that liquid metal is able to dissolve the solid metal, or that liquid metal gets absorbed as a thin layer on the surface of the solid metal. So this is what is going to happen. So in the first case, that is dissolution of solid metal by liquid metal. Example for this one is mercury. Mercury on the surface of gold. Solid metal is gold, upon which if mercury comes in contact, then it is able to make a gold to involve in corrosion reaction. That is, by involving in dissolution, gold is totally getting corroded by the liquid metal mercury. So, and what is the second case? Internal penetration of any liquid metal. Internal penetration of any liquid metal, that is adsorption of any liquid metal onto the surface of the solid metal. If you notice the case of nuclear reactors are meant for releasing, or we can say producing or generating nuclear energy. And in that cases, these reactors will work at very high temperatures, and these nuclear reactors are made up of steel. These are made up of steel. As they are working at very high temperature, we have to make use of coolants. Say for example, if I use liquid sodium as a coolant, then it is able to get adsorbed as a layer on the surface of the steel, that is nuclear reactor body. So coming to liquid metal corrosion, there are two different chances for liquid metal corrosion to take place. That means first condition is the solid metal should come in contact with any liquid metal at high temperature. If this happens, there are two chances for corrosion reaction to take place. That means mechanism part. One is either it gets dissolved in the liquid metal, or liquid metal gets adsorbed onto the surface of the solid metal. And further, the two examples we studied. So in today's session, so far what we have discussed is dry theory or dry mechanism of corrosion reaction. This is again divided into three different types. One is oxidation corrosion, that is purely due to the attack of atmospheric oxygen only. And second one is corrosion by other gases other than oxygen. If any atmospheric gas is going to attack the metallic surface, then this type of theory will be applicable. And the third one, it is liquid metal corrosion. So in the coming session, we are going to study about wet theory of corrosion reaction. That means how corrosion reaction will proceed due to electrochemical attack. That type of mechanism we are going to discuss about in the coming session. So that's all for today's class. Thank you very much. Have a nice day.